Good morning. Myself, Anuj Pisar, and we are Team Koestler. Our problem statement title is FloatChat AI-powered conversational interface for ARGO ocean data discovery, which comes under theme miscellaneous. The ocean is a vital part of our planet's climate system, supporting marine life and influencing weather patterns. Programs like ARGO deploy thousands of floating sensors across the world's ocean to collect important data such as temperature, salinity, and biogeochemical parameters. However, this data is stored in complex formats like NetCDF and requires specialized tools and expertise to access, query, and analyze. As a result, many potential users, including students, researchers, and policymakers, struggle to use of this valuable information. To address this challenge, we have developed FloatChat, an AI-powered conversational interface that enables users to easily explore ARGO ocean data using natural language. Now, the next slide will be explained by my teammate Koestler.
Thank you, Anuj. Oceanographic data is massive and complex. Right now, ARGO floats data require technical skills, NetCDF handling, and code knowledge. Our solution is FloatChat, a conventional chatbot that leads anyone query ARGO data in natural languages. For example, a user can simply type, "Show me the salinity profile near the equatorial in March 2023. The chatbot will fetch live data from Argovis API, process it, and show the table, plots, and AI summarize. These make ARGO data accessible not just to researchers but also for educators, students, and policymakers. The uniqueness of FlowChat is that it's first kind of ARGO focused conversational tool that combines LLM AI, live API access, and interactive dashboard. It bridges gap between raw data and people who need insight. The next slides will explain by my teammate Parth.
Thank you, Kaustubh. Now I will walk you through our technical approach, which has two parts, technologies and methodology. On the tech side, our backend runs on Python 3.13 with Streamlit for the UI styled in the Figma-inspired design. For data handling, we use Pandas, Numpy, and richest, combined with the Argovis API for ocean data and our custom final chat engine. For AI, we integrate Mistral LLM through OpenRouter to generate domain-aware responses. Here's how it works. Argovis validates our API key and returns float profiles in JSON, while Mistral, accessed via OpenRouter, processes queries and generates responses. Our methodology is straightforward. First, queries are passed to capture time, location, and intent. Then, data is fetched from Argovis, processed into Pandas data frames, summarized with stats, and finally, visualized as plots, tables, and chat history on Streamlit. With that, the next slide will be explained by Mohit.
Thank you, Parth. Now let's talk about feasibility. Can this system actually be built and will it work? FloatChat is built on open APIs and open source tools, so it's low cost, lightweight, and can run on laptop or cloud virtual machine. Of course, there are challenges. ARGO coverage is sparse, large queries can slow things down, and wedge questions may cause confusion. Our solutions are chunking for large queries, smart defaults for wedge questions, and clear error messages. On viability, it's economically low cost with future revenue options like subscriptions, freemiums, and partnerships. Socially, it empowers students, NGOs, and policymakers. In short, FloatChat is technically feasible, economically smart, socially impactful, and operationally ready, robust, scalable, and future-proof. Next slide will be explained by Kapil.
Thank you, Mohit. Now let's talk about impact and benefit. Imagine if ocean data could be understood by anyone, not just scientists. That's exactly what our solution does. We make complex data simple and useful, helping students and researchers to learn faster, giving coastal communities practical insights for fishing, and supporting industries like shipping, aquaculture, and tourism. We also empower policymakers and NGOs with real-time information so they make smarter decisions and spread awareness. Our platform is easy to use, accessible to all, and designed to save both times and efforts. In short, we make ocean data easy, practical, and impactful, connecting research communities, industries, and government, and turning raw data into meaningful actions for everyone. So for the next, we have our prototype, which will be explained by our teammate Parth and Anuj.
This is the UI of our chatbot. Now I will ask the chatbot to give me data of average temperature of Pacific Ocean of 2022. As you can see, the flowchart is thinking. The flowchart has given the output now. The average temperature of Pacific Ocean in 2022 was 16.5 degrees Celsius, that is 61.7 degrees Fahrenheit. Now I will ask the flowchart to give me data of each month in table format. Now the flowchart is fetching information It uses Mistral LLM for better response and Argovis API key for accurate information. And here is the month by month temperature data of Pacific Ocean in a table format.
Now, after pressing the new conversation tab, we are giving prompt that give the current salinity of Indian Ocean. And now the FloatChat is thinking and it will give the accurate answer for the question. The current salinity of Indian Ocean is 34.8 practical salinity units PSU. In the UI, we have FloatChat logo on the left top corner. There is a new conversation tab for starting new conversation. After that, there is a demo graph tab. After pressing, it gives graphs. FloatChat is loading the graphs. There is a temperature graph in starting, then salinity graph. After that, the comparison between temperature and salinity, and in the last, all ocean data stats. In the left side, we have recent conversation where you go through previous conversation and at the end we can clear the history. Now Anushka will conclude the project.
After exploring the prototype here, there are key data sources and tools for our solution. Tucker introduces Argovis, addressing ARGO data challenges and providing an API for faster delivery and visualization. NOAA NCEI confirms open access to global ARGO float archives, ensuring data transparency and reliability. The Digital Ocean blog explains RAG, which is the AI backbone that merges real data with language models. The Argovis API docs give official references to fetch and manage float data. The Mistral AI docs detail the LLM model and API views for intelligent and context-aware responses. The SIH 2025 problem statement defines flowchart goals and query requirements guiding our design. In conclusion, the ecosystem links trusted global data, retrieval-powered AI, and interactive visualization. It turns complex ocean datasets into accessible insights, supporting disaster alerts, sustainable marine planning, and resource management, while staying scalable and economically feasible for governments and communities.